Hi, I'm Wendy, Whirl the Science Girl. Welcome to my lab. I was just getting ready to do a science experiment. Are you a junior scientist? Do you love science? Would you like to see this experiment? It's going to be a chemical reaction. Don't you just love chemical reactions? I know I do. Let's make some elephant toothpaste. Here's what you're going to need to do that experiment. You're going to need a water bottle, a half a cup of hydrogen peroxide. Now I'm using the kind of peroxide that you would just get at the drugstore, but if you wanted to, you can even get a stronger solution of hydrogen peroxide, a higher percentage, and the higher the percentage, the bigger the reaction. But sometimes peroxide can't be safe. So in order to be safe, I'm just using the kind that you can get at the drugstore. You're going to take a funnel and a half a cup of hydrogen peroxide and add it to your empty bottle. Okay. I want my elephant toothpaste to look like mint toothpaste. So I'm going to add a few drops of some green food coloring. That'll make it look really neat. And you're going to need to put in a drop of some dish detergent. All right, now it's ready. Now over here to the side, I've taken 2 tablespoons of warm water and I've mixed in 1 teaspoon of some yeast. That's what's going to cause the reaction. Now, I've stirred up my yeast in my warm water until it's kind of dissolved in the water. Now, I've placed my water bottle in a small dish so that it can capture anything that comes out. And to make sure that I'm safe, you always want to have some glasses or some safety glasses nearby. All right, let's get ready to cause a reaction. It's really working. Here it goes. I've got elephant toothpaste. How cool is that? Isn't that neat? With just some things that you might have at your house. Science is pretty amazing. You can come by the library in the next week or so and you can pick up a kit that's going to have some different science experiments in it. The supplies that you're going to need for some science experiments in it. Let's do those experiments. Hi, let's do another experiment. One of my favorite experiments is making a hologram. In your little pack, you're going to have 2 pieces of plastic film that look like this. What we're going to do is, for this experiment, you are going to need some tape and like an iPhone or some kind of a device where you can get YouTube videos. All right? So what you're going to do is you're going to take the film, and it's already been scored for you, so you're going to bend it where those lines have been cut, right on the corners. So bend, bend, and bend it. Then with a piece of tape, you need to put the sides together and tape along those sides, the open sides, with a piece of tape. And when you do that, you should have something that looks like a little pyramid. Okay? It's a little pyramid that has the top cut off, kind of like this. A pyramid with the top cut off. Now, what you're going to need to do is you're going to need to access a YouTube video that has holograms. Now, in our video, we're going to supply the link because parents, you do need to be careful. Some video links or some videos on YouTube are not necessarily appropriate for children, so you do want to make sure that you access the correct videos, all right? And when you do, you're going to take your little pyramid, You're going to put it in the middle of the phone and then press play. And when you do, you have an image that forms in the middle of your pyramid. Well, you might be wondering, how does that work? So let's talk about the science behind a hologram. The hologram is working because of the way light is reflected. You've got light that's coming up from the phone, and the image is coming up, and when light travels, it's going to travel straight. When it comes to the plastic, it's going to bend and be reflected. So as light is coming in from all the different sides, it comes together with an image, all right? It's kind of working the way ready?
Mm-hmm.
It works on the principle of Pepper's ghost. There are 4 symmetrical opposite variations of the same image that are being projected, like I said, up through the 4 faces of the pyramid, and then each side is bent or projected into the middle of that pyramid. And when the 4 images come together, it creates a 3D image. It's kind of like how magicians have used, did you know that magicians have used this technique for hundreds of years for their magic tricks? And if you've been to Disney and have been to the Haunted Mansion and wondered, how did they make that ghost appear in your ride? They've used this same technology. It's magic. What am I saying? It's not magic, it's science. Hi, let's get ready for another experiment. Now, in your science kit bags, you're going to find a baggie that has a bar of soap in there. Let's get ready. You know what I really want to do? Let's blow up this soap. What? I can't blow up the soap? I really wanted to blow up some soap. I know. Can I use the microwave to blow up the soap? All right, let's use a microwave to blow up some soap. So for this experiment, you're going to need access to a microwave and some kind of a microwave safe plate, or even a paper towel would work. So you're going to find that bar of soap that's in a little baggie in your in your science kits. All right, let's get ready to blow up some soap. It's been wrapped in some wax paper.
It's kind of to help keep the smell from getting on everything else that's in your kit. You ever noticed that happens sometimes?
All right, when you've gotten your soap unwrapped, just put it on your microwave safe plate. Open up your microwave and set it inside. Close the door and let's microwave it for 2 minutes. Now you may want to watch through the little window to watch the soap expand. Cool. Whenever you get ready to pull it out, now remember that the plate is going to be a little hot. So you want to make sure that you wear some pot holders or a towel, or get a grown-up to take it out of the microwave for you. Let's see. Wahoo! Let's take a look. Oh man, look at that. We blew up some soap. If you were to handle this soap, if you touch it, it's going to feel really warm. It's also going to feel very, very dry. Have you ever wondered, like, what makes this soap blow up like this? You have to understand some of the properties of science in order to understand why this experiment works. Now, this particular experiment just works with ivory soap. Now, you could try it with some other bars of soap and kind of compare. But here's the special thing about ivory soap. Ivory soap is made by being whipped. Soap molecules are whipped with air in it. If you've ever felt a bar of regular soap and felt a bar of ivory soap, if you were to weigh them, ivory soap is very light because it has so much air inside the soap. And so did you know that air contains water? Water molecules are in the air that we breathe. And so it kind of works something like this. Let's imagine that this red gear is a water molecule and it's surrounded by softer soap molecules. As the microwave heats up, the water molecule starts to heat up. When molecules heat up, they start to become more active. And so the water molecule starts to get active and it starts to move around and it pushes the soap molecules out of its way. Then the water molecule turns into gas. It changes its state of matter. Did you know that water can change its state of matter? So all the water molecules that had been trapped in the bar of soap have now evaporated back into a gas. And that's why the ivory soap feels so dry and powdery. Isn't that really cool? Isn't that neat how science works? It's going to be a fun activity for you to do. You can even kind of play around with this and make it a sensory station at your house. Plus, it makes everything smell so clean. Hi, let's get ready for another experiment. You know, this summer I went to the beach, and when I was at the beach, I was noticing that the sand was absorbing all of the water as it was hitting the shore. And I thought to myself, Wendy, Whirl, the science girl, I wonder if there's a way to make waterproof sand. Let's make waterproof sand. In your bag, you're going to have a little baggie that's got some sand in it. Now, when we started, this sand was just ordinary play sand. But I've coated the sand in a hydrophobic compound, Scotchgard. And it will be something, a hydrophobic compound is something that repels water. You know, if you put Scotchgard on your furniture, it's going to keep it from getting stained. So I thought, what if we get some sand and spray some sand with Scotchgard? I wonder if it would make our sand waterproof. Let's give it a try. So for this experiment, I just have a tray. It's always handy to kind of keep a tray under your work. That way you keep your table clean. I've got a little vase or a cup, and I've just got some ordinary water in there. So you can take your sand and kind of pour it in to your water and see what it does. Cool. Look what it's doing to my sand. Isn't that neat? It's kind of like I could form some stalactites or stalagmites inside my my glass there. And it all is repelling the water that I've just poured it into. Now, if I want to, I can reach down there and I can scoop out some of that sand. And look what happens when I pull it out. It goes back to being just plain dry sand. And when I pour it back in, it clumps back up again and repels the water. How neat! I've just made waterproof sand. So this will be a fun activity. You can play and play and play with it. You can even maybe take another container if you want to save your sand and pour off the water. Until you've got your dry sand again. Spread it out, dry it out, and play with it over and over again. We just made magic sand. Hi, let's do another experiment. Inside your science kit bag, you're going to have a little Ziploc baggie that has some little things that look like colorful beads. Tiny little beads. These are water beads. They are created using a polymer. Now polymers expand. It can expand to 150 times its diameter by adding some water. Now let's do some science with these water beads. One of the things that I wanted to suggest, a lot of times what people normally do and what we're going to do is just take the water beads and put them in a tub with some water and then watch them expand over time and then use them as a sensory station. But one of the other things that you could also do is maybe do some science with them. What about I would like to suggest that you take a few water beads, just like 3 or 4, and put them in some cups. And then maybe try some different experiments, seeing what expands the water beads the best. What if you put some water beads in some vinegar? Or what if you put water beads into some pop? Would they expand? Which one would expand the best? I don't know. That would be a neat experiment to do. But with the rest of your water beads, let's just have some fun watching them expand in water. So what you're going to need is some kind of a tub or a container and then some water. Now, the purer the water, the better the water beads work. If there's any kind of chemicals or salt in the water in your water, then those things don't pass through the membrane of the water beads. It just absorbs water. So you're going to need to put your water beads into a tub of water, and then you just have to wait. I know. I'll build something. Do some building. See if I can build a cube. beads have absorbed the water, and now they're at full size. So now you can kind of play with them and have a fun sensory experience with water beads. And it's all through the science of polymers. Hi, let's do another experiment. This time, let's talk about force and motion. In your kit, your science kit that you're going to pick up, you're going to have some of the components that you're going to need to make maybe a balloon car, a car that's going to be powered by air power. And in your kit, you're going to have 2 straws, 2 sticks, 4 wheels, a little green kind of mouthpiece, and a balloon. Now, here's what I did when I first tried to make a car. I saw all the things that I had, and I knew that I was supposed to make a balloon car with it. So I looked around my lab, and I found a piece of cardboard. And I thought, well, that seems like that would make a pretty good base for a car. So I took my straws, and I took some tape, and I started to build a car. I put some tape down. And then I needed for my wheels to attach to it. So I took my 2 sticks and I poked them through the foam wheels. There's kind of a little dot on your wheels too, so that you kind of know where the center of the wheel is. My upper hand. Then I wanted to make sure that my wheels were attached to my base. So I took some more tape. Right now, my base is too big. So I guess I'm gonna need to trim some off. Take my scissors, cut it a little bit smaller. And now, I bet I can attach my base. There we go. I'm making a car. But when I put my car on the table, I noticed that my wheels didn't really move very easily. And I thought, maybe I need to think about this a little bit more. What I really need is I need for this part of my wheel, I need for it to be in something so that it will roll. Wonder where I could find something that was kind of like a tube that I could put this rod through so that my wheels would roll. Where could I find a tube? And then I thought, wait a minute, these straws are tubes. What if I took the straw and I cut it in half? Then I could put the kind of stick through it and put my wheel back on. If I can get that back on there. And now I've got a fixed axle. So now it can stay stationary, but my wheels will move. That's kind of how a car works. I think I'm onto something. Whenever you're trying to do some engineering or design something, sometimes you have to go through a process in building. You have to think about what you're going to build. Then you come up with a plan and start to build it. And whenever you start figuring it out, you may hit some problems along the way. You may need to go back and think about what the problem is and come up with a new plan for your design and keep working it and tweaking it until you come up with something that works. So now that I've come up with a way for my wheels to move, now I needed something to put them on. Well, I could still use a piece of cardboard, but I thought, what if I had a soda earlier in the day? What if I made my soda bottle into a car? And so that's what I did. I cut holes in my soda bottle, and I was able to put my fixed axle through the holes, and then I put the rod piece with my wheels. So now I have something that will move like a car. But now it needs some power, and this is where the balloon comes into play. Balloons, you can use a balloon by funneling the force of the air that comes out of the balloon as your power. And so you could take the little green mouthpiece, you can put a balloon on it, and what this is going to do, this is going to allow you to blow up the balloon as well as kind of funnel the air in the direction in which you want your car to go. You may need some help with this. I would kind of stretch your balloon out a little bit and blow it up a couple of times to make sure you kind of get the stretch going so that you can blow it up easily. You may need for a grown-up to help blow your balloon up for you. Sometimes it can get a little tiring. Let me see if I can clear a path. So if we can get our balloon car to go, maybe it'll travel across the table. I'm going to move that to the floor. Move everything out of the way. Let's see if we can make this work. Now, I've already got a piece of tape positioned on my little blower, because what I'm going to do whenever I blow it up, I'm going to hold it. I'm going to blow and hold, so I can keep the air from escaping. And when I get it blown up, I'm going to try to attach it to my car. Now, you want to make sure that your balloon doesn't kind of come in the way of your car. So you want to make sure that it's kind of towards one of the ends so that the air can escape, right? All right, so I'm holding it, and I'm going to put my little blower on there. Let's see if we can... Woo! We made a balloon car using the force of air and experiencing motion. We created an axle that helped our wheels to be able to move, and we did some problem solving along the way. You might have to do that as well with your balloon car. Maybe look around your house. Like I said, I used a pop bottle, but you could use maybe a cardboard tube or some Legos or just about anything. You could take this balloon car apart, take the parts apart, and kind of rebuild them into something else. See what you could build using an axle, some wheels, and some balloon air power. Here's another experiment where you can use the force of air to create motion. But this time, instead of a car that's going to travel horizontally, let's do a hovercraft where it's going to kind of glide over the table. In your kit, you've got the makings of a little hovercraft using a CD that's got a bottle cap on it and a balloon. You need to blow up the balloon, twist it, and then put it on the cap of your CD. Then put it on the table, and as it untwists, you've got a hover car. Hi, let's do another experiment. Let's make a robot. I'm Wendy Whirl, the science girl robot. Our robots cool? Do you know how robots work? Sometimes robots might use the power of electricity and electrical currents. In your bag, in your science kit, you're going to have a little Ziploc bag that's got the components to make a bristle bot. You're going to have a little toothbrush head, a motor, a battery for power, some pipe cleaners, some googly eyes, and some adhesive, like a little kind of double-sided adhesive tape. All right? Here's what you can do to make a BristleBot robot. You're going to take your little toothbrush bristle head, and you need to cut your adhesive tape, maybe cut it in half, okay? You're going to place it on the head of the toothbrush. And now what you're going to need to do is you're going to need to create an electric current, okay? So you're going to take this motor, this little motor. It has a spinning little gear on the top, and it has 2 wires coming from it. In order to create a circuit, you're going to need to have a negative and positive wire coming off of something. Now, a lot of times you might find that with like little light bulbs, but this time we're going to use this little motor, all right? Now we're going to need to finish the circuit by having a power source. So we want to have our wire, our power, and then our wire again. And when we do that, we've created, a circuit. We kind of have a loop. All right? So now let's take that little motor and let's do that onto the top of our toothbrush head. You want to make sure that the spinning part of the motor is going to be off the back of the toothbrush head. So that way there won't be anything to impede it from spinning. All right? Like I said, we've put the double-sided little sticky tape on there. And I'm going to take one of my wires and I'm going to stick it into that little sticky tape. Ooh, it's really sticky. Now I'm going to take my battery, and it doesn't matter which side is up. I'm going to stick it on top of that wire. Now I'm ready to put my other wire on top. But I know that as soon as I close that loop, right now, my circuit is open. So I don't have power going to my motor. But as soon as I close that circuit by connecting the red wire, I'm going to have a closed circuit, so I'm going to have power. So I want to wait until after I finish creating my BristleBot. I'm going to make my BristleBot kind of look like a bug with the wiggly eyes. They are adhesive backed, so you should be able to just kind of peel off the back and stick your eyes on. Give him some big googly eyes. Also, for some stability, because right now my BristleBot, probably if I turned it on, is just going to flip over on its side. It's going to have so much power going to it. So in order to give it some stability, you might want to take your little pipe cleaners. I've taken one. You should have 2 in your bag. I'm going to take one, I'm going to fold it in half and twist it, okay, to make kind of like a little leg. I can use that leg and I can stick it into the little sticky tape that my battery is also stuck in on. So that now I want to make sure it's balanced so that my BristleBot doesn't fall over. Okay. Now I've got my BristleBot made, so now I'm ready to kind of close that circuit so that my motor will work. I'm going to do that by using the rest of my little sticky. I'm going to stick that on. I'm going to put my red wire. I'm going to stick it to it and then stick my wire. Ooh, there he goes. Now he kind of fell over a little bit, I need to make sure I get my legs on there really good. And I want to make sure my motor is up on his back. There he goes! I made a robot! How cool is that? That is so neat. Oh! There goes our robot. Maybe you can make a robot at your house too. Maybe you could even use those components and create something at your house. Use your battery, use the motor, see what kind of a robot you could come up with. You could find some cool things around your house. Maybe some pool noodle pieces or plastic utensils. What could you use that motor and battery to turn into a robot? Have fun with science! Science is amazing! Get out there and explore more and use your imagination. Whether you are exploring forces in motion, lights, circuits, polymers, or the engineering design process, science is all around you. So from Wendy, Whirl the Science Girl, I'll see you soon.